In this video, we're going to walk through some basic foundational problems related to special orders, make-or-buy analysis, and the best use of a constrained resource. We're going to take a look at the Kane Manufacturing Company that manufactures two products called an alpha and a beta. They sell for $120 and $80 respectively. Each product uses one type of raw material that costs $6 per pound. That's going to be important later on when we do our constrained resource. The company has the capacity to annually produce 100,000 units of each of these products, and its unit costs at this level of production are given below. So here are our per unit costs if we produce and sell 100,000 units. The most important thing we can ever do whenever we see fixed cost expressed on a per unit basis is to convert them to total amounts, because fixed cost per unit is very misleading because that changes as production increases or decreases. So again, very important. Whenever you see fixed cost on a per unit basis, first thing to do is convert it to a total amount. So for the alpha, our traceable fixed cost was $16 per unit. And we talk about traceable fixed manufacturing overhead. Recall that traceable fixed costs are costs that we can be avoided if we discontinue a particular product line or quit serving a particular type of customer. So in the case of our product, let's assume that we're making alphas in one particular factory. Any fixed cost associated with that factory would be a traceable fixed cost. If we quit making the alpha, we close down the factory. We get rid of rent on the factory. We get rid of our production supervisor in the factory. We get rid of our maintenance workers in the factory if they are on a fixed basis rather than variable basis. Any fixed cost associated with that factory will disappear, as of course will the variable cost. So traceable fixed costs will disappear if we get rid of a product. On the other hand, the common fixed costs, these are more of our corporate costs. They won't disappear. They'll simply be reallocated from one product to another. And the Kane Company allocates the common fixed costs on the basis of sales dollars. So let's continue. We had the alphas at traceable fixed cost of $16 per unit. The betas are $18. And again, that's at 100,000 unit level of activity. So our total traceable fixed cost for alpha is $1.6 million, and for beta it's $1.8 million. The common fixed cost, and again, these are simply the ones that we're allocating. They won't change if we get rid of a product line. Alpha is $15 a unit, beta is $10 a unit, and again, at 100,000 level units of activity, total alpha is $1.5 million, and the total beta is $1 million. Once you've identified our total fixed cost, then you can go ahead and do your make or buy analysis, your special orders, and anything else you want to consider. Let's go ahead and consider some special orders. We're told to assume that Kane produces and sells 80,000 alphas during the current year, and one of Kane's sales reps has found a new customer willing to buy 10,000 alphas for a price of $80 a piece. If Kane accepts the offer, how much will our profits increase or decrease? We simply need to calculate our contribution margin per unit. Our variable costs will include direct materials, direct labor, and both variable manufacturing and variable selling and admin. They total $69, so we're making $11 per unit. If we sell 10,000 units, we'll have a $110,000 contribution margin. Again, unless we're told otherwise, there's no change in fixed cost, so our profits would increase by $110,000. Let's take a look at another special order problem. In this problem, we're told that Kane expects to produce and sell 90,000 betas during the current year. And again, our capacity is 100,000 units, so we have excess capacity. One of Kane's sales reps has found a new customer willing to buy 5,000 additional alphas. So 5,000 additional alphas betas, at a price of $39 per unit. Again, we simply need to calculate our contribution margin per unit. Unfortunately, we find our variable costs are $40 per unit. Again, that's materials, labor, variable manufacturing overhead, variable selling. So this would generate a negative contribution margin, and at 5,000 units, we would lose a total of $5,000. We're not saving anything in fixed cost, so it would decrease our profits by $5,000. We don't want to take this order. In this problem, we're told that Kane expects to sell 95,000 alphas during the current year. Again, our capacity is 100,000, so we've got some excess capacity. One of Kane's sales reps has found a new customer that's willing to buy 10,000 additional alphas. So that's going to be a bit of a problem. We only have capacity for 5,000 at a price of $80 per unit. If Kane accepts the offer, of course, it's going to have to decrease its sales of alphas to regular customers by 5,000 units. So the question is, should we accept the special order? So our direct material, labor, variable manufacturing overhead, variable selling was 69. So again, we have a contribution margin of $11. So that same total contribution margin of 110 from the earlier problem. We've got no change in fixed cost, but we're going to lose current sales, and we're going to lose 5,000 units of current sales, and our contribution margin on those sales is $51 per unit. That's the $120 normal selling price minus our variable cost, and we're going to lose 255 trade-off for the 110,000 gain. I don't think so. We would be worse off by $145,000. Now we're going to consider a question about discontinuing one of our product lines. Assuming that we sell 90,000 betas per year, what would happen to our profits if we discontinued the beta profit line? So first thing, we would lose all 90,000 units, and our selling price for the betas, we were told, was $80 per beta. Our variable cost for betas was $40, so our contribution margin per unit was 40. That means we would lose a total contribution margin of $3.6 million. Would we have any cost savings? Well, our only cost savings will be our traceable fixed manufacturing overhead of $1.8 million. So overall, we would be worse off by $1.8 million. We don't want to discontinue the beta product line if we're selling 90,000 units per year. What if, on the other hand, we were producing and selling 40,000 betas per year? What would happen to our profits if we discontinued the beta product line? Well, again, we'd lose the 40,000 units of sales at a selling price of $80 per beta, variable cost of $40, so we lose our contribution margin, a total of $1.6 million, but we will have a savings in fixed cost. We're going to save the $1.8 million in traceable fixed manufacturing overhead. So overall, we would be better off by $200,000. At low levels of production, we don't have enough units to spread those fixed manufacturing or fixed trace costs over to make this a profitable product. At what level of sales would we be different? This is simply a break-even problem. All we have to do is take our fixed cost savings, which is our traceable fixed cost of $1.8 million, and divide it by our $40 contribution margin per unit. And we find at 45,000 units, we would be indifferent. So if we're making more than 45,000 units, we have enough units to spread over our traceable fixed cost over. If we're making less than 45,000 units, we're not covering our traceable fixed cost. Let's consider another break-even or discontinuing product scenario. We're told that Kane normally sells 60,000 betas and 80,000 alphas during the year. If we discontinue the beta product line, our sales rep thinks we could increase sales of alphas by 15,000. So we're going to have a 60,000 unit decrease in betas, but we're going to have a 15,000 unit increase in alphas. Let's see how this plays out. Our normal selling price for betas is $80 per unit. Our variable cost, $40, which means we have a $40 contribution margin. And if we discontinue betas, we will give up $2.4 million in total contribution. But we'll have some savings in fixed costs. We'll be able to eliminate our traceable fixed cost of $1.8 million for betas. Plus, we're going to have that increase in alphas, and our contribution margin per alpha is $51. So we would boost our contribution margin on alphas by $765,000. We would save $1.8 million in traceable fixed costs. That more than offsets the $2.4 million lost contribution margin.